Welcome guys, today we're going to be looking at the cognitive approach and we're going to be outlining and evaluating it today. The underlying assumption of the behaviourist approach was that our behaviour could be explained by learning. However, the underlying assumption of the cognitive approach is that all behaviour can be explained by cognition, which basically just means our internal mental processes such as thinking. Now obviously this presents a bit of an issue because we can't directly observe people's thoughts, so what can we do instead? So one idea could be to use introspection in the same way that Wundt did. So we could show someone a stimulus and ask them to write down everything they're thinking. So write down everything that comes to mind when I show you this picture. However, we're going to run into issues here because not everyone is going to want to reveal everything that comes to mind. So we might see the social desirability bias. So for example, with someone like Nelson Mandela, if I'm a racist, I'm probably not going to write down anything which shows that I'm a racist. Alternatively, we could ask people to directly explain how they're processing information. Explain how your brain separates different kinds of information which need to be remembered in short-term memory. However, this is going to present another barrier because most people don't have insight into how their brain actually processes information on a subconscious level. So introspection is not particularly reliable. Instead, we can make use of something called inference. So inference is where we study the internal mental processes indirectly by looking at the behaviours which we can directly observe. So for example, a dual task study allows us to infer that visual and auditory information are processed by separate stores, as in the working memory model. So the difference in task performance is something we can directly observe, and from that we make an inference about the fact that those different kinds of information are processed by different stores in short-term memory. So cognitive psychologists make use of something called the computer analogy, which basically suggests that humans process information in the same way that a computer processes its own inputs. So you have an input, which would be the stimulus from your environment, information processing then occurs, which is your thoughts, and then an output, which is your behaviour. So in the case of a computer, our input might be someone typing on a keyboard, information processing then occurs in the computer CPU, and then an output is presented, which is the word you then type on the screen. In a human, however, the input might be something like we see a cute cat, the information processing would be our thoughts, so us thinking, what a cute cat, I should go pet him. The output would then be the behaviour we show, such as stroking the cat. So just to recap, we can manipulate the input as an experimenter and measure the output, and from the output we can infer the internal mental processes, so the information processing. And the way we explain this information processing is through theoretical models. So we use theoretical models to represent how our minds are processing information, and the working memory model is an example of one of these theoretical models. So the next thing we need to learn about is schema. So you might have come across these before. So schema are basically just bundles of information about the world which help us to process incoming information. Schema are made up of our expectations for how things should look and how they should behave, and they're constructed through our experiences. So for example, we should all have a schema of a cat. So for 30 seconds, just pause the video and write down some of the features of a cat. Imagine you're describing a cat to someone who's never seen one before. You probably would have come up with something along these lines. It's got 4 legs, a tail, it's furry with whiskers, claws and pointy ears and a button nose, it goes meow and it's a living creature, or something along those lines. So this would be my schema for a cat. However, I've said that it's furry, but is this still a cat? I said that a cat has 4 legs. Is this still a cat? And I've said that a cat is alive. Is this still a cat? I would argue yes, they are obviously all still cats. Even though it doesn't fit my schema, I can still tell that it is a cat. So basically we all have a schema of a cat, and this is our prototypical idea of a cat. It's the cattiest cat that I can possibly think of. When I see something new, such as this, this or this, what my brain does is measure it against my existing scheme of a cat and see how well it fits. If it's close enough to my idea of a cat, then my brain interprets that and says, yep, that's a cat, you're looking at a cat. So that's an example of where our schema can help us. Otherwise, we would need to have a completely separate idea and category of what each of these things were. We wouldn't be able to label them as cats, which would of course be ridiculous. However, it doesn't always work out so well. So here we have something which is a bit more ambiguous. It could be a cat or a dog, so leave a comment, let me know what you think it is, because I'm curious to see what people think, and I will reveal whether it's a cat or a dog next week at some point. So finally, we need to look at cognitive neuroscience. So cognitive neuroscience uses neuroimaging techniques to map those cognitive processes and information processing theories to the brain. So for example, we can use an fMRI scan to show that the different components of working memory are in fact linked with specific and separate areas of the brain, which you can see here. The central executive is linked to the frontal lobe, the visuospatial sketchpad is linked to the occipital lobe, and the phonological loop is linked to the left temporal lobe. Finally, we just need to evaluate the approach. So the strengths of the approach are that there's plenty of supporting evidence for it. So we can use scientific brain scans to show that different areas of the brain are in fact active for specific tasks, and by linking those different components of our theoretical models to specific brain areas, that provides support for the fact that those theories are probably true. Furthermore, it's very scientific, so it tends to use lab studies, which means we have a high degree of control, it's very reliable, we have a good level of internal validity, as well as using objective measures such as fMRI scans, like we said here. Finally, it has a lot of real-world applications, so the cognitive approach, as you learned about in your psychopathology module, could be used to explain and treat mental illnesses like depression. So cognitive behavioural therapy has its roots in a cognitive approach to psychology. It's not without weaknesses though, so it can be described as machine reductionist, which basically just means that it reduces human beings to machines. So the computer analogy says that we process information in the same way as a computer does, but are humans really the same as a computer? I would argue no, because it doesn't factor in that human beings feel emotions and computers don't. So one weakness of the cognitive approach is that it doesn't account for the fact that humans have emotions. And finally, it may lack ecological validity. So where our strength here is that it uses lab studies, which makes it more scientific and therefore has higher internal validity, the fact it uses lab studies also means it therefore must lack ecological validity. So that is all you need to know about the cognitive approach. I'm going to put a task up for you which I need you to complete over Easter, and that will be due back the first Monday after Easter, so you've got like 2 weeks to do it.